Hello and welcome to T3 Day 14 of Honors Precalculus. We're going to talk today about probability. So let's warm up by counting a few things first. So suppose a pizza shop makes cheese pizzas and then has 10 different toppings. So there's 10 different toppings you could add to a cheese pizza. How many possible 4-topping pizzas can they make? Now, one of the things you have to realize is that it doesn't matter what order you choose the toppings in. Because, for example, a pepperoni, mushroom, and sausage pizza is going to be the same thing as a sausage, pepperoni, and mushroom pizza. It doesn't matter what order. So in this case, it's going to be 10, choose 4. You can use your calculator to find that, and that is 210. The order does not matter. Now, here's one that's a little bit harder. It says, how many possible different pizzas can they make total? Well, they could make a pizza with no toppings, and that would be choosing 0 toppings. Or they could make a pizza with 1 topping, or they could make a pizza with 2 toppings, or the pattern continues with 3, all the way up to, they choose 9 toppings. So sorry, I'm writing to 9 again. So it's 10, choose 9, all the way up to 10, choose 10. So that means you could have no toppings, 1 topping, 2 toppings, 3 toppings, 4, 5, 6, 7, 8, 9, and 10. You'd have to do all of these separately and add them together, and that comes out to be 1,024. So there's actually 1,024. This takes a little while because you have to add these all together, but 10 choose 0 would be just a cheese pizza, and then 1, 2, 3, 4, all the way up to 10 choose 10, which is there's only 1 with all 10 right there, like a supreme or whatever sometimes that's called. But you'd have to do this carefully. So here's a probability question you might have worked out before. If you roll a 6-sided die, what's the probability you will roll a 4? Well, there's only one 4, and then there's 6 possible things that can be rolled. On top, you have the number of winners. There's a number of ways to win this. What's the probability that you will roll a 4? There's only one way to roll a 4, and then it's the number of possible outcomes. So what this means is you have a 1 out of 6 chance of rolling a 4, which is 0.1667, or 16 if you round to 2 decimal places, 0.67% chance of happening. So remember, it is the number of winners over the number of possible outcomes, and that's going to be your probability. And the other most common thing to play with in terms of probability is decks of cards. So if you randomly draw 1 card from a standard deck of cards, which is going to be 52 cards total, what is the probability you will choose a queen? Well, this necessitates you know that there are 4 queens total in a deck, a regular deck of cards, and there's 52 cards total, so that's going to be 0.769, which is 7.69% chance of happening. Remember, 100% chance, or if this was a 1, that would be certainly happening, or if this was 100%. So in this case, it's just 7.69%. Here's the technical definition of probability. If E is an event in a finite non-empty sample space of S of equally likely outcomes, every outcome is likely. What that means is, like in a 6-sided dice, every side of the dice here, every side of the dice has the same probability of happening. Then the probability of the event happening is the number of outcomes in E, so this is the number of winners right here, over the number of outcomes in S, which is the number of outcomes total. So it's the number of possible things on the bottom, and it's the number of winners on the top. So how many ways can you win the game? Over the total number of ways possible. How many different ways could you play the game? So sometimes we use NCR on our calculator, NPR on our calculator, or we can just count things up straight up. What I mean by that is, suppose you roll 2 dice. What is the probability that the sum of the 2 dice is 7? What about 5? Well, you might try to set up some complex thing using NCR, NPR, or you can just write out all the possibilities. Here's what they look like. So what you can think of this as is the first dice is 1, the second dice is 1, first dice is 2, the second dice is 1, first dice is 3, the second dice is 1. So this represents all the different ways you could roll a 2 6-sided dice. So what do you see here? What do you see right here? This is where the sum is 5. The sum is 5. So what that means is there are a total of 4 ways for the sum to be 5, but then how many ways are there to roll the dice possible? Well, you can see that there's 6 times 6 entries, so that's going to be 36. So the sum is 5 is going to be 4 over 36, which is 1 out of 9. And then what about the sum is 7? The sum is 7 right here on this diagonal, and I see 6 of them. So that's going to be 6 out of 36. So that's 1 out of 6. Now you can write these as percentages. 1 out of 9 is 0.1111 repeating. So that's 11.11%. And 1/6 is going to be 0.1667 rounded. Again, that's rounded up. So that's 16.67%. 2 decimal places is okay. So it's more likely that you have a sum being 7 than you do with a sum being 5. But again, the takeaway here is sometimes it's easier just to list out all the things and count them up manually than to try to use NCR and PR. So let's talk about the lottery here. To win the jackpot in a Powerball lottery, you first must pick 5 numbers out of 1 to 69 and then choose one number from the numbers 1 to 26. Suppose you buy 1 lottery ticket. What's the probability that you'll win the jackpot? Well, there's only going to be 1 winning outcome here. What's the number of winning outcomes? 1. There's 1 winning outcome. But what's the number of possible outcomes? Well, how many you have to choose? You have to pick 5 numbers out of the numbers 1 through 69. It doesn't say anything about the order, so this is just choose. So that means you have 69 to choose from, and you're choosing 5 of them. But then you're multiplying, then choose one number from the numbers 1 to 26. You have to get that one correct as well. So this right here represents the number of outcomes. Again, you're just choosing 5 numbers. It doesn't matter what order they're chosen in, but you have to choose the right 5 numbers from 1 to 69 and then one number from 1 to 26. When you do this out, it turns out to be 1 over 292,201,338. That's very, 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 very small. That's the probability of it happening. That's very, very, very small. It's like that's 1 person out of less than the population of the United States. So what about this one? It says a card is randomly chosen from a standard deck of 52 cards. What is the probability that the card is either a face card or a spade? This is where we need to know things about decks of cards. There's 12 face cards. There's 12 face cards. That's kings, queens, or jacks. And there's, and then there's 4 suits, so there's 1 of each. And then how many spades are there? Or a spade. So it's 13 spades right here. 13 spades. But the thing is, this overlaps because there are 3 face spade cards. There's 3 face spades. What that means is, in this set here, there's 12 face cards and there's 13 spades. Well, there's 3 of them in this set. So then there's that overlap. So you double count them if you were to add together just 12 and 13. So if you do 12 plus 13, you get 25. You have to take away 3 and you get 22. So there are 22 out of 52 ways to get this, which is going to be 0.4231, which is 42.31%. Again, the reason we take away 3 face cards is because there are 3 face cards that are also spades. So if you did 12 plus 13, you'd be counting 3 of the cards twice. So you have to be careful of double counting. So in this case, Sal opens a box of a dozen chocolate creams that all look alike. 4 of the 12 are vanilla. If he chooses 2 at random, what is the probability that they are both vanilla? This is pretty fun. So there's 4 ones that are vanilla. So how many possible ways are there to play this game total? Well, the game, so to speak, is choosing 2 at random. So how many possible outcomes are there? Well, there's going to be, you're choosing from 12, you're choosing 2 chocolates, and it doesn't matter what order. So this is the number of possible right here. The number of possible ways to play the game is you're choosing 2 from the 12. And then what about the winning outcomes? Well, there's only 4 of them that are vanilla, and you're choosing 2 of them. So when you do this, you end up with 6 out of 66, which is equal to 1 out of 11, which is 0.0909 repeating. So it's actually 9.09%. So it's pretty low. So again, there are 4 vanilla and you're choosing 2 of them. So therefore there are 6 ways to do that because that's what 4C2 is. And then over here, there's 12. The number of possible ways, 12 and 2. You're choosing 2 of these from the box of 12. So this is the number of possible outcomes, which is 66. So suppose you roll a die twice in a row. What is the probability that you roll a 3 and then a 4? Well, the number of possible outcomes, how many different ways can you roll a dice twice? Well, there's 6 ways the first time and 6 ways the second time. And then how many possible ways there to roll a 3 then a 4? Well, there's only one possible way to roll a 3 then a 4, and that's you roll a 3, and then a 4. So this is 1 out of 36, which is 2.78%. And that's how we like to write our probabilities. So what we did there is actually we used independent events. So if there are two independent events that have no bearing on one another, then the probability of both of them occurring is the product of the individual probabilities. So what's the probability of rolling a 3? Well, that's 1 out of 6. What's the probability of rolling a 4? This is on a 6-sided dice. That's also 1 out of 6. The probability of both of them happening is the product of the two, which is also 1 over 36, the same as above. Remember, if they're independent, the probabilities of both of them occurring is the product of the individual probabilities. So again, this is the probability of rolling a 3. This is the probability of rolling a 4. So the probability of both happening, you multiply them together, you get 1 out of 36. So this would be the probability of a 3, then a 4. So it says, suppose you are dealt one card from a standard deck and then a second. What is the probability you will get a 3 and then a face card? So again, what is the probability that you will get a 3? So we're getting a 3, so we need the probability to get a 3. The probability of getting a 3 is going to be, there are 4 different 3s in the deck, so the probability to get a 3 is 4 over 52, because there's 4 3s and there's 52 total. But then you're picking the second card from the same deck, because you dealt one card from a standard deck and then a second from the same deck. So that means the chance of getting a face card right here, a face card, how many face cards there are there? Well, there's no overlap. 3s are not face cards. So there's 12 face cards, but there's only 51 cards left in the deck because we took one of them out. We took the 3 out. So what does that turn into? That turns into 4 times 12 over 52 times 51. You do this out on your calculator and you get to about 1.81%. But again, this was taken out of the same deck. So the probability of first pulling a 3 is 4 because there's 4 3s and 52 cards total. But then after you take a card out, there's 51 left. And then how many face cards there? There are 12. So you do this out on your calculator and you get 1.81%, about that.